Let us discuss this example. See, in this example, we have to find the value of integration by changing the order of integration. See, in previous videos already we have seen what is meaning of order, change the order of integration. That means if the original strip is parallel to y-axis, we consider a strip parallel to x-axis, and if the original strip is parallel to x-axis, we rotate it and we consider the strip parallel to x-axis, we find the new limits and we solve the double integration. So this is a method, okay. So this integral we have. So the inner integration is with respect to x. So these are limits of x we have. X is equal to, okay. So obviously these are limits of y. So with the help of these limits, first of all, we will find the region of integration. After that, we will rotate the strip and then we will find new limits of integration. Let us find the region. Region is bounded by, okay, y is equal to 0. So you know that y is equal to 0. This is equation of what? X-axis, right? Let me show here. So y is equal to 0 we have, right? Next, y is equal to 2. So y is equal to 2. It is a line parallel to x-axis, okay, which passes through y is equal to 2. Let me draw the line. Okay, line parallel to x-axis which passes through this y is equal to 2. So we will have line like this, okay. So this is y is equal to 2. Let me show here. Next, x is equal to 5. So x is equal to 5. Again, it is a line getting which is parallel to y-axis. A line parallel to y-axis which passes through x is equal to 5. Where is x is equal to 5? 1, 2, 3, 4, 5 here. So we will have line like this, okay. So I am showing it here. So this is x is equal to 5. So the point of intersection obviously 5, 2. Okay, point of intersection of these two lines. Let us go further. One more curve we have, that is x is equal to 1 plus y square. Let me write it here. See, x is equal to 1 plus y square. See, power of x is 1, power of y is 2. So 100% it is a parabola symmetric about x-axis since x has power 1. But let me write it in its standard form. So that is y square is equal to x minus 1. I should write here x minus 1. Getting? So that is, I will write in a more proper way, that is y minus 0 square, it is equal to x minus 1. So this is a parabola symmetric about x-axis. I will say positive x-axis since x has plus sign, and vertex at 1, 0. Let me mention that thing. A parabola symmetric about x-axis and vertex at, okay, vertex at 1, 0. Where is 1, 0 here? So this is 1, 0. We have, okay, which is symmetric about positive x-axis, opens in a direction of that left hand side, and yes, vertex at 1, 0. So we have a parabola like this. So this parabola will definitely cut this line x is equal to 5. Okay, so let us find a point of intersection first so we can draw that parabola easily. X is equal to 5. You know that how to find a point of intersection. We put for one equation in second equation. By solving, we will have point of intersection. If I put x is equal to 5 here, what will we get? Y square is equal to 5 minus 1, 4. Y square is equal to 4. So y is equal to plus minus 2. That means y is equal to 2 and y is equal to minus 2. At these two distinct points, this parabola will cut this line. Getting? So that means parabola should pass through this point and this point. Let me draw the rough sketch of parabola. It will be like this, okay. And I should draw parabola here which passes through this point. See, in this way we got the parabola. Let me write here. What is its equation? Its equation is y square is equal to x minus 1. So the region is bounded by y is equal to 2. Region is bounded by y is equal to 0. That means our region lies between these two lines. Bounded by x is equal to 5 and this parabola also. So this region will satisfy all these conditions. Okay. So this is our region of integration. Let me show it here properly. So this is region of integration. So now consider the given integral. So we have an integral this one. So the inner integration is with respect to x. That means original strip or the given strip is parallel to x-axis. We have to change the order of integration, so we should consider a strip parallel to y-axis now. So let me show it here. So we have a strip, we should consider a strip parallel to y-axis. Okay. See, after that, we need to write that thing. The strip is bounded below, bounded above, those things we need to consider, but there is no more space to write, so make a screenshot of it. After that, we will go further. So I mentioned that thing there, okay. So to change the order of integration, we consider strip parallel to y-axis, right, as shown in this diagram. So then we should write y varies from, and after that we write x varies from. Funda is very simple, bounded below, bounded above, left to right. Strip is bounded below by x-axis, whose equation is y is equal to 0. I should write 0 here. Strip is bounded above by a part of parabola, whose equation is y square is equal to x minus 1, but I have written y is equal to. We want y is equal to. To get y is equal to, I will take square root of both sides. So y is equal to square root of x minus 1. So maybe you will think, when you take square root, there will be two possibilities, plus and minus. See, but we are in upper half of parabola, okay, on this side. So that's why I'm considering a positive root. If you consider this part of parabola, that means which lies in a negative y-axis direction, that in that part, then we should consider minus square root. Okay, so we are on this side, so that's why I'm considering positive square root. After that, we move strip from left to right. So our strip should start at this point, okay, to cover each and every point of a region where the value of x is 1, and strip will move like this, and it will go up to this line where the value of x is 5. So in this way we got limits of integration, okay. So therefore I is equal to integration 1 to 5, integration 0 to root x minus 1. What is our function? Y e raised to x minus 1 square dy dx I should write now, since our strip is parallel to y-axis. Initially we had dx dy. Now we have got dy dx, that means we have changed the order of integration. Let us simplify the problem now. Okay, we will solve this integration. This is equal to integration 1 to 5, right? See, we are integrating with respect to y now. So all functions of x will come outside. So this e raised to x minus 1 square, that is a function of x only. So I will take it outside the integration. E raised to x minus 1 square. So inside the integration, we will have y only, whose integration is y square by 2. So let me mention that thing here. So this is y square by 2 with limits 0 to root x minus 1 dx. See, we always take, okay, we always take constants outside. So we have 1 by 2 here, so which is a constant. Let me take it outside. 1 by 2 integration 1 to 5 e raised to x minus 1 square. I'm putting upper limit. If you put upper limit, we will have square root of x minus 1, but we are taking square, so square and square root will get cancelled to each other, and we will have simply x minus 1. And if you put 0, if you will have 0, no need to write anything. Okay, so I will continue with this one, dx. Okay, so there is no more space to solve this problem, so make a screenshot of it, then we will go further. Okay, see, we in this integral we have x minus 1 e raised to x minus 1 square. It is complicated, okay, to solve directly. So what will I do? I will use substitution. So normally we put such thing whose derivative is easily available. So I am putting x minus 1 square is equal to t. So its derivative is, you know, the derivative of x square, which is 2x. So similarly, its derivative will be 2x minus 1, okay, and again derivative of this bracket, which is 1. So this is a derivative of this bracket. After that we write dx, and on that side we write dt, since derivative of t is 1. Fortunately we have x minus 1 dx, same term we have got. So just I will shift this 2 on that side. So we will have x minus 1 dx is equal to dt by 2. When we put anything, we find derivative and we change the limits also. Let us change the limits now. So we have values of limits of x 1 to 5. Let us find new limits. Okay, we are finding limits of t. If I put 1 here, 1 minus 1, 0 we will have. If I put 5 here, 5 minus 1, 4 square, which is 16. Right, so t is equal to 16. So therefore, I is equal to new limits 0 to 16, right? After that, see, 1 by 2 is there, so I should write 1 by 2 here. E raised to e raised to what we will have? T only, since x minus 1 square, which is equal to t. X minus 1 dx, we can replace it by dt by 2. So this is dt by 2. So that 1 by 2 is constant, we can take outside. So 1 by 2 into 1 by 2, 1 by 4 we will have. Integration of e raised to t is e raised to t. Okay, so you will have same. So let us use this space to write. So this is equal to 1 by 4. Now I am putting upper limit at a place of t. Okay, so e raised to 60 minus, if I put 0, e raised to 0, which is equal to 1. So this is 1. Okay, so this is value of given integral. Okay, so we change the order of integration and we got this as a final answer. Make a screenshot of it, then we will stop. Thank you. Bye bye.